Hi everyone. So this is part 2 of implicit differentiation, chapter 3, section 5. I will be doing example number 2 and example number 3. This is on page 209 and the next one is on page 210 or 210. I actually worked this problem out a little bit earlier. It wasn't that difficult. There was a little bit of things I had to adjust for, but it wasn't that difficult to do. Looking at example number 2 first, you have x cubed plus y cubed is equal to 6xy. You want to find at 3 comma 3, find y prime. That's part A. Okay. So what we want to do at this stage is we want to just take the derivative respect to x again. I am going to go a little bit faster on this because it's just like example number 1, except a little bit faster. X cubed, the derivative of that will be 3x squared times dx over dx, which is 1, plus the derivative of that is going to be 3y squared times the derivative of y. This is the chain portion of y. That's going to be just y prime. Equals, on the right hand side, I factor out the 6, always factor out the constant or the coefficient, derivative respect to x of x times y. Well, this is a product of two variables, x and y, right? So you have to use the product rule, which is unfortunate, but you still have to do it. 6 times the derivative of the first, which is 1 times y, the second, plus the derivative of y, which is dy dx, which is just y prime, times x. We're going to distribute that out and clean it up as you go. 6 times the first, it's going to be 6y. 6 times this, it's going to be plus 6x times y prime. On the left side, you get 3x squared plus 3y squared times y prime. Notice this term, there's a y prime. You have to move it to the left side. Notice this term, 3x squared, you have to move it to the right side. I'm going to do it in one shot. I'm going to move 3x squared to the right side by subtracting 3x squared. I'm going to subtract 6xy prime to the left side, and so you get rid of that right there. And then at this stage, since you have two terms, the first term and the second term, you can factor out y prime. You end up with 3y squared minus 6x is equal to, on the right side, you have 6y minus 3x squared. Solving for y prime, since you factored it out, you have to divide by this. So y prime is equal to 6y minus 3x squared all over 3y squared minus 6x squared. You can actually clean this up a little bit if you want. Factor out of 3, you end up with 2y minus x squared. Factor out of 3 here, you end up with y squared minus 2x. Cancel those out, and you end up with this as your answer for part A. Almost. You want to find the slope at 3 comma 3. So what do we do at this stage? We're going to go to the right a little bit. Now we're going to use it here. Let's do it here. At 3 comma 3, it's going to be 2 times 3 minus 3 squared all over 3 squared minus 2 times 3. That's going to be 6 minus 9. Negative 3 over 9 minus 6 is positive 3, which is negative 1. So I'm going to look at my answer. Oh, they want the equation of the tangent line for part A, right? So what we're going to do is you're going to use the slope right here that we just found out. You're going to give, we are given this point, which is 3 comma 3. So y minus y1 is equal to m times x minus x1. Y minus 3 is equal to negative 1 times x minus 3. Keep it in point slope form. And that's it. I'm going to erase this and do part B for you. Part B gets a little bit more tricky. Okay. So let's go to the second portion. The second portion is read, find the tangent line. Oh, that was part A. Actually, that was part B. So this is part B. This is part A, which was, I believe, I erased it earlier. Y prime is equal to, what was it? 2y minus x squared over y squared minus 2x. Okay. And then part C is a little bit more tricky. It says in quadrant 1, find the point of the horizontal line that is tangent. So as soon as you see tangent horizontal line, you're going to use the derivative, right? That is tangent to it. So what we do is we set the derivative equal to 0. That's where the tangent line is horizontal. So when does this fraction equal to 0? It's when the numerator equals 0. So you end up with 2y minus x squared is equal to 0, moving the x squared over. 2y is equal to x squared divided by 2, y is equal to x squared over 2. That's the relationship between x and y. You have your original relationship, which is x cubed plus y cubed equals 6xy. We're going to plug in x over 2 in for your y right over here. Substitute. So let's write it out. Always point as you go. That way you kind of know where your focus is. X cubed plus x squared over 2 cubed is equal to 6 times x squared over 2. Sorry about that. Okay, so we're gonna work out this. You end up with x cubed plus x squared over 2 cubed. Cube the numerator, cube the denominator. It's gonna be x to the 6th over 8. And the 6 and 2 cancels, 1 and 3. It's end up with 3x cubed. I'm gonna subtract x cubed to the left side, set it equal to 0. X cubed, I'm sorry, let's do that. Let's do this term first because it's the highest power. X to the 6 over 8 minus 2x cubed. You see how I moved 3x squared to the right side, to the left side? Set equal to 0. And solve for x. Factor out x cubed. You end up with x cubed over 8 minus 2 is equal to 0. We set each factor equal to 0. So it's going to be x cubed equals 0. I'm going to erase this. Already done with part B. And so x cubed equals 0. The other factor is x cubed over 8 is equal to 0. Oh, minus 2 is equal to 0. So what do we do here? X cubed cannot equal 0 because this is not in quadrant 1. And then we're going to set this. Solving for x, move the 2 to the right. X cubed over 8 is equal to 2. Multiplied by 8, x cubed equals 16. 16 is the same thing as 2 to the 4th. 2, 4, 8, 16, right? So you have 4 fingers here. So solving for x, what we're going to do is instead of cube rooting it, we're going to raise it to the 1/3 power. It's the same thing as cube rooting, right? So as a result, we're going to end up with cubed and 1/3 cancels. Their inverse operation. X equals 4 to the, excuse me, made a simple mistake here. You end up with 2 to the 4/3 power. And that's your x value. Oh, by the way, I did work that out on my calculator. That happens to be approximately, I believe, 2.5198. If you use your calculator and you do it on the AP, you should go to the 4 decimal place on your calculator for the AP exam. And so how do you find out what the value of y is? Well, since we know the relationship between x and y, which is located right over here, I'm going to underline this for you, or y is equal to x squared over 2, y equals x squared over 2, And then we're going to plug this in here for my x value. 2 to the 4/3 squared over 2. That would be y equals, what's 2 to the 4/3 squared? We power to power distribute, which is 8/3 over 2. I'm going to put a little 1 here. That way you know that since we have a power of 2, base of 2, we can just subtract the exponent. That becomes 2 to the 8/3 minus 1. Minus 1 is just 3/3. It's going to be 2 to the 5/3. That's my y value. Okay. Y to the 5/3, I believe is 3.1748. Okay. I'll show you what I just did. I'm going to turn this calculator on. And 2 to the 4/3 is right here. 2 point, as you can see, it's going to be 2 point, I'm not sure if you can see that or not. And then if you use the bottom one as well, 3.1748. Okay. And that's example number 2. Let's do example number 3 really quickly. Let me clean this up a little bit. And so what happens is when you do these problems, you want to move all the dy dx terms to the left side usually, and then factor it out, because you will always be able to factor out dy dx, and then solve for dy dx by dividing by the other factor. Let's try a little bit more difficult problem, example number 3. I'm going to go really fast on example 3 this time. So you have sine of x plus y is equal to y squared cosine of x. What's the derivative with respect to x of sine of x plus y? Well, we take the derivative of the outside function, which is the sine, and the derivative of sine is just going to be cosine. Inside stays the same, x plus y, times the derivative with respect to x of the inside, which is x plus y, the chain portion. The derivative of x is going to be 1 plus the derivative of y with respect to x as dy dx. And that's going to be multiplied by that factor. Okay? And so when we take the derivative of the left side and the right side, always do the derivative with respect to x. And you want to say it out as you write things down, because well, as you say it, it will help you to explain to yourself the questions a lot better that way as well. So on the left side, we end up with this. Cosine of x plus y times 1 plus y prime, that's right there, equals. Now we have to take the derivative of the right side. Now you notice it's a product rule, right? Y squared times cosine of x. I just take the derivative of the first, which is 2y times y prime, times the second, which is cosine of x. I'm going to clean this up a little bit so we have a little bit more space. Plus the derivative of cosine of x, which is sine, negative sine of x, times, the derivative of x is just 1, right? Times y prime, y squared. Excuse me. I'm going to distribute this out. I have to distribute and to get the y prime by itself somehow. So I end up with cosine of x plus y plus y prime times cosine of x plus y equals 2y cosine of x times y prime minus, there's a plus and a minus, I made minus, y squared times the sine of x. I'm going to move this term to the left side, and I'm going to move this term to the right side. So let's do it in one shot. I'm going to factor out, subtract cosine of x plus y. So I took that out right there. And I'm going to move this term. How do I move this term? I subtract it, right? Minus 2y cosine of x times y prime. And there's a little plus right there. So I got rid of this term. There's something I can do at this stage because there's two minuses there. I'm going to run a negative, multiply everything by negative. You end up with plus here, minus here, plus here, and plus here. So that makes it a little bit easier to deal with. And then I'm going to actually at this stage factor out y prime too. So if I factor out y prime, the first term I have plus 2y cosine of x, and then there's a minus right there. I factor out y prime, you end up with cosine of x plus y equals, on the right side I have y squared sine of x plus cosine of x plus y. And then what I do is I take this and I divide it by that right there. So y prime is equal to y squared sine of x plus cosine of x plus y all over 2y cosine of x minus cosine of x plus y. I'm going to just check my work on that. Example number 3. The answer for that is on the top of page 211. Y squared sine of x plus cosine of x plus y over 2y cosine of x. Yep, I get it. Just right. Okay. Good luck on example number 4. It's a little bit more difficult. I'll work on it a little bit later. Thank you. Sorry it took a little bit longer.